Now let's go to class number 5 for the IB Mathematics standard level course. Class number 5 is now we've covered all types of functions. Now we'll cover rational functions. Let's start. To go with the rational functions, the general form of the rational function is f of x is equal to ax plus b over cx plus d. The most important thing to know about this function are the asymptotes. We have, for this function, two asymptotes. We have a vertical asymptote and we have a horizontal asymptote. Number one, let's start with the vertical asymptote. The vertical asymptote is an equation with x that makes the denominator equal to 0, because we can't have the denominator equal to 0. So to find the vertical asymptote, we have the function, our function is equal to ax plus b over cx plus d. For the vertical asymptote, I need to find the value of x that makes the denominator a 0. So I make cx plus d is equal to 0. So now the equation or the vertical asymptote is equal to x equals minus d over sc. This is my vertical asymptote. Number 2, we need to find our horizontal asymptote. Horizontal asymptote is an equation of y. The horizontal asymptote, we can find the horizontal asymptote when x goes to infinity. So to find the horizontal asymptote, we need to find f of infinity, which is equal to a times infinity plus b over c times infinity plus d. Now, since this constant, the b, won't affect the infinity, we have it as a times infinity over c times infinity. And in the denominator as well, the constant d won't affect the infinity. So we have a times infinity over a c times infinity. The infinity with the infinity will cross out. So I'm having my horizontal asymptote is y equals a over c. Simply the coefficient of x in the numerator over the coefficient of x in the denominator. We can see an example. Let's say I want to sketch f of x equals 2x plus 2 over x, let's say plus 4. Now all we have to know are our vertical and horizontal asymptotes. If I want to find now, start with the vertical asymptote is when the denominator is equal to 0. So I have x plus 4 is equal to 0, so x is equal to minus 4. This is my vertical asymptote. For the horizontal asymptote, it's simply the coefficient of x in the numerator over, or we can apply the infinity, which is equal to times the infinity plus 2 over x, which is infinity. Here I have an infinity or plus 4. Like I said before, the plus 2 won't affect the infinity, so I'm having 2 infinity over infinity plus 4. Also the plus 4 won't affect my infinity, so I'm having 2 infinity over infinity. These infinity will cross out, I'm having 2. So my horizontal asymptote is y is equal to 2. So if I want to draw my graph, I'm having, this is my vertical axis, and let's draw a horizontal axis. This is my horizontal axis. What I noted now that I'm having a vertical asymptote at x equals minus 4. This point is minus 4. This is x equals minus 4, and a horizontal asymptote at y equal 2. This is my horizontal asymptote. This value here is 2, and this is the equation of this line is y is equal to 2. Now, to know what shape I do have, I can sketch it using my GDC. Let's go to our GDC. This is on. We'll start. We can go to our function y. We can clear all the functions, clear function 1 and clear function 2. We go to function 1. We have 2x plus 2 over x plus 4. Go alpha, y, okay. Now, we put the f of x, this function 2x plus 2 over x plus 4, in our first function y1. So we use a bracket here, and I'm having 2x plus 2 divided by x plus 4. Let's graph our function. I can't see the whole function. Why? Because I have to change the window. I have a problem in the window. Let's change our window. Let's go to window. Let's make the x minimum as minus 6. The x max as 6. We can, this is the y scale, the y minimum as minus 6 and the y max as 6. And now we can graph it. Still, we can't see our function clear enough, so we have to make our window larger. This is minus 10 with 10, and the y from minus 10 to 10 as well. Minus 10 with 10 graph. Okay, now I have a clear vision of my graph. This is, I can graph it now. It's like this. This is my sketch. I need to show these intersections here. Let's go back to our GDC because it shows everything. If you want to find the x-intercept, which is this one, we can go to second calc, the 0. The 0, it means where the function is 0, which means I'm finding the x-intercept too. I'm having, this is x, this I want the left bound. I go to the left at the intersection, I press and enter, and then I go to the right of my x-axis intersection. Then I go to the guess, which is in the middle here. I guess it. So the 0 is when x is equal to minus 1. So this intersection point, this intersection point is -1 with the 0. Now let's find the y-intercept. Simply the y-intercept on x is equal to 0, or we can find it using our GDC. We go second calc. Second calc, we need to find the value. We press 1. We need to find the value of the function when x has a value. So when x is equal to 0, we need to find the value of y. Press enter. Simply we can find that y is equal to 0.5, which is a half. So this value here is 0 with 0.5, which is a half. By this, we finished our sketch. But if you want to check that your asymptotes are correct, simply we can apply in the GDC. If we want to check that the -4, there is an intersect at the -4, we make a second calc, press 1 for the value, we insert the x as a -4. If there is an asymptote there, your calculator will show an error. We can check, enter, there is an error. No y value when x is equal to -4. The same thing we can do it when y is equal to 2. We can draw a line and find the intersection. If there is no intersection, then also it's an asymptote. I hope it's clear till now. Now we can go to solve a function, which is, yes, it's a function. Question on a function from the question bank. This example here, I'm having f of x is equal to 3x over x minus q. I'm having my f of x is equal to 3x over x minus q, where x is not equal to q. Okay, write down the equations of the vertical asymptote and the horizontal asymptote of the graph. First, we start by the vertical asymptote. We've said that the vertical asymptote when the denominator is not equal to 0. So I need x minus q is equal to 0. So my vertical asymptote is x equal to q. The horizontal asymptote when x goes to infinity, I need to find the f of infinity, which is equal to 3 infinity over infinity minus q. Here the minus q down won't affect the infinity, so I'm having a 3 infinity over infinity. These infinities cross out, so the horizontal asymptote I'm having it is y is equal to 3. This is my horizontal asymptote. If we can do a fast sketch that would help to do section B, we'll make the axis here. I have a vertical asymptote at x equals q and a horizontal asymptote at y equals 3. This is y equal to 3. Since I don't know q, I have to go to section B so I can know it. In section B, the vertical and horizontal asymptotes to the graph of f intersect at the point 1 and 3. 1 and 3, it means this is the equation of the horizontal asymptote, I have it, and this is the equation of the vertical asymptote, x is equal to 1. So my equation for the vertical asymptote is x equal to 1. Part B wants to find the value of q. We've said before that I have x minus q is equal to 0 to find the vertical asymptote. And since I knew my vertical asymptote from what's given in section B, simply I substitute 1 instead of the x. So 1 minus q is equal to 0, giving us q is equal to 1. And by this, we solved our question. In this topic, the most important thing to find the asymptotes, sometimes you have to find intersection in the graphs, and that's it.